You're standing on the surface of Venus. Well, not really standing, you're being crushed. The air pressure is squeezing you with the force of being a kilometer underwater. Your body is cooking at 475 degrees Celsius. Sulfuric acid is raining down. You have about 3 seconds before everything goes very, very wrong. So here's the question. Could you ever actually live on this nightmare planet? The answer is yes, but not down here. You need to go up. Let's get you off this hellscape and figure out what we're dealing with. You're rising now fast. As you ascend, let's talk about why the surface is impossible. Venus is Earth's evil twin. Similar size, similar gravity, but that's where the similarities end. The atmosphere is 90 times denser than Earth's. Imagine the pressure a kilometer underwater, but everywhere. It's almost entirely carbon dioxide, which means you can't breathe it. The temperature is 475 degrees Celsius, hot enough to melt lead. And those clouds? Sulfuric acid. The Soviet Venera probes that landed here in the 1970s lasted about an hour before being cooked, crushed, and corroded into scrap. 10 kilometers up, still 450 degrees Celsius. Still utterly lethal. 20 kilometers, 350 degrees Celsius. Getting better, but you're still being baked alive. 30 kilometers, you're entering the acid cloud layer. Not great. 40 kilometers, temperature dropping fast now. And then, at 50 kilometers above the surface, everything changes. You check your instruments, and you can't believe what you're seeing. Temperature, Y-30 degrees Celsius. Room temperature. Like a nice day on Earth. Pressure. 1 atmosphere. Exactly the same as sea level back home. Gravity. 0.9 grams. Almost identical to Earth. You've just found the most Earth-like environment in the entire solar system, excluding Earth itself. But here's the question. How do you stay here? Here's where it gets interesting and surprisingly simple. Think about helium balloons. Helium floats in Earth's air because it's lighter than the air around it. The lighter gas rises, the heavier gas sinks. Basic physics. Now, Venus's atmosphere is almost pure carbon dioxide. CO2 is heavy, much heavier than the air you breathe. The air you breathe on Earth is mostly nitrogen and oxygen. That mixture is significantly lighter than carbon dioxide. So on Venus, regular breathable air acts like helium does on Earth, it just floats. You don't need to fill your habitat with some special, expensive gas. You don't need to constantly burn fuel to stay aloft. You just fill a sealed container with the same air you've been breathing your whole life, and Venus's thick CO2 atmosphere pushes it upward. The bigger your habitat, the more air inside, the more it wants to float. It's like a hot air balloon, except you don't need the hot part. Room temperature air floats automatically. Your home literally stays aloft just by being filled with the air you need to survive anyway. It's almost too elegant to believe. But the physics checks out. Oh, but here's the catch. The margin isn't as generous as it sounds. The density difference between breathable air and CO2 is real, but it's not huge. That means your habitats have to be large and lightweight. Think blimp, not space station. Every kilogram of structure, every piece of equipment, every person inside is weight that has to be offset by more volume, more floating air. Okay, so let's say you solved that problem. Now you can float. But can you actually live here? Let's break down what you need to survive. Air to breathe? You're literally surrounded by it. Your habitat is filled with 78% nitrogen and 21% oxygen, the same air you breathed on Earth. The habitat itself becomes your balloon. Protection from the environment? You're above the densest acid clouds, but you still need sealed structures. Think of it like a space station, but instead of keeping air in against vacuum, you're keeping Venus's CO2 out. Your walls need to be acid resistant, but we already have materials for that: Teflon, certain plastics, treated metals. Energy? Look up. The sun here delivers twice the solar energy that Earth gets. Your solar panels are generating power constantly. And because Venus rotates so slowly, one day lasts 243 Earth days, you get incredibly long days for solar collection. You store excess in batteries for the long nights. Water? This is your biggest import challenge. Venus's atmosphere has almost no water. So you're doing chemistry, extracting oxygen from CO2, then combining it with hydrogen brought from Earth, or eventually mined from asteroids. The reaction gives you H2O. You recycle every drop like it's gold. Food? You walk through the agricultural dome. Vertical farms stretch above you, plants growing in aeroponics and hydroponics. They breathe in the CO2 you exhale, they breathe out oxygen. The intense sunlight makes them grow faster than on Earth. You're growing lettuce, tomatoes, potatoes, protein-rich algae. It's not a perfect diet, but it works. Radiation protection? Unlike Mars, Venus's thick atmosphere shields you from cosmic radiation and solar storms. You don't need to bury your habitat underground or pile meters of regolith on top. The atmosphere does the work. But let's be honest about the challenges, because you're experiencing one right now. Alarm sound. A small puncture in Sector 7, a micrometeorite strike. Not big, but enough. On Earth, a leak means inconvenience. In space, a leak means you lose air. On Venus, a leak means you sink. Your habitat is losing buoyancy. The altimeter shows you're descending. 49 kilometers. 48. The temperature is rising. You're sinking toward the acid clouds, toward the crushing pressure, toward the heat. This is the razor's edge you live on. Your entire civilization floats on precise atmospheric chemistry. Lose too much lifting gas and you sink into hell. Rise too high and you hit the cold upper atmosphere with its own problems. The repair crews are already on it, patching the hull, pumping air back to full pressure. Within 30 minutes, you stabilize. Within an hour, you're back at 50 kilometers. You've survived. But the incident reminds you, this is a place that requires constant vigilance. Then there are the other challenges. Psychological, you can never touch the ground. You can never go outside without protective gear against the acid. You're in a perpetual twilight, drifting with the winds at 100 meters per second. Supply lines. Everything you can't make here has to come from Earth 86 million kilometers away at closest approach. If something breaks and you don't have spare parts, you wait. The unknown. We've never built a floating city. What happens during Venus's massive atmospheric superrotation? How do you anchor structures together? What about long-term material degradation from acid exposure? So can you live on Venus? Let's answer honestly. Is it physically possible? Yes. The physics work. The chemistry works. At 50 kilometers altitude, Venus offers Earth-like temperature, pressure, and gravity. Breathable air floats automatically. Solar power is abundant. You can manufacture most of what you need. Is it technologically feasible? Probably. We're not talking about science fiction here. No warp drives, no artificial gravity, no unobtainium. We need acid-resistant materials, airtight structures, solar panels, and life support systems, all things we already have or understand. The engineering is hard, but it's the kind of hard we understand. Is it practical? That's complicated. Getting to Venus is easier than Mars in terms of delta V, but landing is impossible and floating is untested. You're building an entire infrastructure in the sky with no ground to stand on. Is it livable? Here's where you are now, looking out your window at the other habitats drifting in formation with you. You wake up every day to a view of alien clouds and brilliant sunlight. You breathe recycled air and eat hydroponically grown food. You work in labs and factories that float on wind currents. You exercise in 90% Earth gravity, so your body stays strong. You've adapted to the swaying sensation of living in a balloon? Is it comfortable? Not like Earth. You can't go for a walk outside. You can't feel rain on your face. You can't dig your hands into soil. But it's viable. Humans are living here, working here, maybe even being born here. You head to the observation deck as Venus's long sunset begins a process that will take weeks. Could we ever live on Venus? You're doing it right now. It's not easy. It's not what anyone imagined when they dreamed of space colonization. You're not walking on solid ground or terraforming a planet. You're floating in a bubble of breathable air, 50 kilometers above a world that would destroy you in seconds. But here's what you've learned. Livable doesn't mean comfortable. It means survivable with technology and determination. By that definition, Venus specifically, the narrow band of atmosphere at 50 kilometers is livable. You need sealed habitats, constant maintenance, imported resources, and people willing to live on the edge. But you needed all of that for submarines, for Antarctica, for the ISS. This is just the next step. Below you, the clouds churn. Above you, the stars emerge. Around you, a city floats on nothing but air and human stubbornness. You're living on Venus, and somehow, against all odds, it's working. Welcome home.